Hello everyone. Today we'll be looking at logarithms, the laws, properties, and its exponential equations. So what are logarithms? Logarithms, also known as logical arithmetic, are linked directly to exponentials and is used to solve many exponential equations. So this is an example of a logarithm. So let's look at its parts. The log is the operator, a is the base, y is the argument, and x is the power. So this is a simple power equation. So a is the base, x is its power, and y is the argument. The argument is basically the power of the base. So the book definition says that the logarithm of a number to a given base is the power or index to which the base is raised to give the number. So this is an actual example. So log 381 is equal to 4. This is because 3, which is the base, to the power of 4, which is the power, is equal to 81. 81 is the argument. So now, on to the laws and properties. The first law is the addition law. This states that when two logs add together, the argument multiply each other. However, this is only the case if the base, which is a, is the same. The second law is similar, except when two logs subtract, the arguments divide each other. And the third law is the power law. This states that when the argument, which is x to the power of n in this case, has a power, n, the power can be moved in front of the log. For these three laws, we'll prove them in another video. So, other properties. So, log a1 is equal to 0. However, a cannot equal to 1 because a to the power of 0 is 1. And 0 to the power of 0 is undefined, so it can't be 0. Another property is that log a is equal to 1. A must be 1 because 1 to the power of 1 is 1, and that's the only option because the power and the argument is the same. 0 to the power of 0 is undefined. So the final property is log a 1 over x is equal to log a x to the power of negative 1. So in powers, if you have a power of a negative number, then it means that it's just a reciprocal. So x can also be written as x to the power of 1. So, and this is the reciprocal of x. So it has to be negative 1 as the power. And in law 3, we know that the power can be moved in front of the log. So it's negative log a x. So now let's move on to exponential equations with logarithm. So here is the basic formula or structure of a logarithm, and it can be also written as this. So we tried to convert all the logs to base 10, mainly because calculators, they can all calculate with base 10, but not all calculators can calculate with like base 2 or 3. So it suits all calculators. So we change the base to 10, and it's log 10y. However, in here we know that y is equal to a to the power of x, So we can substitute it in, so these two equal each other. And then, from the law 3 of the logarithm laws, we know that the power can be moved in front of the log. And to single x out, all we have to do is divide log 10y by log 10a. And that's your result. And that's it for the lesson. Thank you for listening, and I hope you learned something new. If you have any questions, you can put it into the comments below, and don't forget to like and subscribe if it was helpful. See you in the next video.